So in this video, we're going to go through the Arduino itself. So if you haven't seen it already, this is the Arduino. This is basically a printed circuit board, so a circuit with particular components laid on top. So what makes this an Arduino is mainly the form factor, so the size of it and where the pins are, and the programming language that you use to communicate to it. So we'll have a look at that part later. What we're going to do here, however, is step through the components. And so this is useful mainly so that you can understand what is going on. And so you can be a little bit more aware of how you're going to be connecting into this, what each part is doing, and how to identify the core parts. So let's get started. The main part of this board is the Arduino microcontroller itself. So this is an Atmel chip. It's this one here. You can see that it has pins along the side, and these are actually broken out to the edge so that you can access them more easily. This particular style of chip is called a DIP, dual inline package. Not that you need to know that, but it's just useful. This chip is responsible for being the brains of the system. It's responsible for understanding the inputs, executing on the outputs, and processing how to interpret that via what code you put in. So you make up what the chip is actually thinking, so the thoughts of it. The next important part are the breakouts on the side. This is where you connect external items to the Arduino board. So these particular headers allow you to put wires into them, and that's how you electrically connect external items. So along the top, we've got the digital section. And so let's step through each of those. The first ones, 0 and 1, are labeled RX and TX. RX is receive data, TX is transmit data. So these two are special in that they're used for communication. So there's other ways of making the other ones be used as communication, but these are the default. So when you upload things via USB, it actually is communicating through this particular chip onto the RX and TX pins that connect into the microcontroller. So when you go to use it, try not to use 0 and 1 until you get to a little bit more advanced, because you might get interrupted by, say, the USB communicating or the serial communicating. The rest of the pins, 2 to 13, can be used as digital inputs or outputs. So those ones are the ones you want to use. There's a special little marking there, the tilde, indicating that it's pulse width modulation capable, PWM. So we'll go through that in a later video, but basically it allows it to turn on and off very fast to simulate an analog signal. At the top end here, we've got ground. And so that's used for completing circuits and analog reference that we don't need to get into just yet. Down the bottom, we've got the analog input outputs. So they're prefixed with an A. So we go from 0 to 5. You'll notice that in these pins, we always start with 0. So in computer terms, 0 is a number as well. So we actually start there. So these analogs, you can go from 0 to 5 volts and it will read and understand any part in between, as opposed to the digital that it only understands a low voltage or a high voltage, approximately 0 or approximately 5 volts. The analog understands things in between. Going on, then we have the power section. So we've got VIN, voltage input. So when you want to power the device externally, you can feed voltage in there. Alternatively, you can also do it through the DC power jack here. Next, we have 2 grounds for completing circuits again. And then we've got 5 volts and 3.3 volts for powering circuits. And finally, we also have the reset, which is used to reset the controller, usually from the use of shields. You'll notice that these particular pins are staggered in a very particular way. This is so that there's additions called shields that plug on top. These shields, because of how they're staggered, allow it not to get orientated the incorrect way. Shields allow you to add functionality to it in a very standard way, and we'll have a look at that later. Other important parts are the USB jack, which we use to connect it to the computer. So it understands the protocol USB from the computer, translates through this chip into something called serial that the Arduino can understand. When serial is used, or the RX and TX is used, these two lights light up. So whenever you upload a program, or if you're reading back from it using the serial terminal that we'll see later, these two LEDs light up. So it's a good confirmation. We also have another LED on here indicating on. And this particular one is special. It's connected to pin 13, so it's an onboard LED just for doing some tests, and that's exactly what we're going to do in the next section. There's also a reset button. This is responsible for bringing the program all the way back to the start. So just in case you want to test the start of a program, you can always push that. And finally, an interesting part here is the crystal. So this little tin box here is responsible for keeping time, or think of it more as a drummer on a boat, making sure that the rows happen at the right time, just calling out the count. So using this particular item, which it uses it by default, it's just how it operates, it keeps time. So basically what happens here is an electrical signal is applied to the crystal. It resonates at a very fixed frequency and it keeps time. So when you ask the microcontroller to wait 1 second, it knows how many beats from the crystal to wait. And that's about it. This is the most standard Arduino that you can get. It's the standard form factor. There's lots of different kinds of Arduino. They have the same components, but they might be in a different shape. So we've got smaller ones for smaller projects. We've got different shape ones like the lily pad that are used for clothing style projects because they accept conductive cloth a lot better. But this is the one that we're going to be working with.